Welcome to my demo presentation on the learning models to predict mRNA-based degradation rates. So this is the structure of the demo. I will be covering the following aspects of the project in the demo. I will be talking about how the data gets loaded. I will give a brief explanation on the different graphs that have been used for data visualizations and what they represent. I will give a brief explanation on how the three models on the project works, and I will demonstrate on how the website works and demonstrate its different features, including the responsiveness. So let's get to the code. So the different header files has been imported at the start of every model, and we have created three models here, which is the LGBM regressor model, the WaveNet model, as well as the GRU and LSTM model. The data sets, the training and the test data sets, has been loaded using pandas, and the submission file has also been loaded using pandas. The train and test datasets are in the .json format, while the submission file is in .csv format. The train and test datasets has been converted to lists first, and then column heads has been added to the lists, and finally they have been transformed to the data frames. Histograms has been used to show the distribution of different target variables in the first 25 samples of the dataset. This dataset has also been transformed to data frames. Now, the base pair probability matrices here has been loaded. BPPS, or the base pair probability matrices, are the pre-calculated NumPy arrays for each RNA sequence that gives the probability that each pair of nucleotides in the RNA forms a base pair, and BPPS for the first 25 samples has been loaded here. The structure of the submission file has been shown here. The values of the target features in the training set has been rounded off to 2 places after the decimal. A KDA plot has been used to show the distribution of the signal-to-noise feature, and the dataset comprises of RNA sequences of 2 lengths, 130 and 107 in the public test set, and bar plots has been used to show the distribution of these 2 different ranges of RNA sequences. The mean values of the target features has been calculated here, and they has been visualized using histograms. The distribution of the different values in the target features has been visualized using graphs. Pair plots has been used to show the relationship among the different target features. The model has been trained using LGBM regressor, and this is what the final score looks like. The mean values of the predicted target features has been represented using histograms. These values has been stored in the sample submission file. And we can see that the predicted values are very close to the original values. Rec plots has been used to show the multicollinearity of the first 25 samples of the target features. This is for the reactivity. This is for dec mg50 Celsius. This is for dec mg pH10. This is for dec pH10. And this is for dec 50C. Okay. So now this is the section for the WaveNet and the GRU. So similar to the LGBM regressor model, the datasets and the submission file here has been loaded using the pandas in this case. The different characters in the RNA sequences has been enumerated in a dictionary. The training and test datasets has been subjected to 3D transformation based on the enumeration format. The training model has been built and the wavelength layer, the wavenet layer has been added. Hidden layers optimizers has also been added. The evaluation matrix chosen is column-wise root mean squared error. The model is trained and evaluated. This is what the final root mean squared error has come out to be, and the results, the predicted results, has been stored in the sample submission file. Now, similar to the previous two models, this section also loads the datasets using pandas, and all the header files gets imported at the start. The shape of the training and the test dataset has been checked. The structure of the sample submission file has been checked. The signal-to-noise ratio distribution has been visualized using KD-plot, and the signal-to-noise filter distribution has been visualized using bar plots. The training set has been transposed to show the different values under each column. KD-plots has been used to show the distribution of the BPPS max, BPPS-sum, and BPPS-NB. The dataset has been subjected to 3D transformation similar to that of the previous model. The evaluation matrix used is in column-wise root mean squared error. The training model has been built and it has been trained using LSTM and GRU layers respectively. This is what the final value looks like in case of the GRU layer. And this is the final training error in case of the LSTM layer. Line graphs has been used to show the training and validation losses for the GRU and LSTM. Now from the results obtained, we can see that without the SN filter, the predicted values comes out to be higher than the original values, while with the SN filter equal to 1, the SN values are almost equal to that of the actual values, and this is exactly what we want. The results from the two RNNs has been blended and finally have been stored in the sample submission file. Now let's quickly go to the website that we have created. So the website has 4 pages. This is the welcome page. This is the No More page, and the No More page has detailed information about the project. The A-site section on the No More page here has links to different sites related to COVID-19 and mRNA vaccines, and so it links to different sites. And at the bottom of the page here, we have a link that leads us to the models page. And we can also use the menu above to serve to the models page. The models page summarizes all the results from the project, all the graphs and the results that we have had from the project. And finally, we have the play page, which has links to the models and the No More page. And it also has the link to the Eterna Games page, which is the starting point for this project. Now, finally, let's check the responsiveness of the website. We can see that the website is responsive. So that's it with the project. Thank you so much for watching.